So welcome back to another episode of LifeSci AI, the podcast series. This is the penultimate episode in our series, and luckily we are joined by the CTO of NICO.LAB this morning, Dr. Renan Sales Barros.
Not doctor yet.
not quite doctor yet. Almost a doctor.
Almost
a doctor. Almost. So we're joined by almost doctor.
I get my title. Yeah.
So I'll read it. We are joined by almost Dr. Renan Sales Barros, CTO of NICO.LAB, and we're very lucky to be joined by Renan today because NICO.LAB have been in the news recently. So I'll let Renan introduce himself and a little bit about NICO.LAB and perhaps why you guys have been in the news recently.
Yes, definitely. So yeah, we received like substantial investment from our Australian investors. It's around 13 million Australian dollars to help us, build NICO.LAB even further. It's been quite a journey, with the COVID and a lot of talks, but yeah, it's for me as the CTO, I see the money, I'm just like, okay, now there is a lot more work to do, right? Because now I have the resources, so I have to use those investments well and expand the team, because there is quite a lot of cool stuff to do indeed.
Yeah, no, for sure. Exciting times, lots of things for you to do.
Yeah, don't get me started. Yeah, the to-do list grows every day. Yeah, but I think maybe it's also nice if I tell a little bit about NICO.LAB. And first, people always ask us who is NICO, and there is no NICO at the company. NICO in NICO.LAB stands for Neurovascular Imaging Core Laboratory. So when we founded the company in 2015, I was the one registering the domain, and that was the only domain free available. We are just students, PhD students. I still am PhD candidate. And yeah, we together with our CEO Renan Barros, we've been working developing algorithms for processing CT scans from stroke patients since 2013 here in the academic hospital in Amsterdam, the so-called IMC. And well, in the beginning, we were doing research, right? So everything that we were developing was more focusing on research. That's also why we have the lab on the name of our company. One of our first clients was like pharmaceutical companies doing clinical trials for stroke patients. So basically, they wanted to measure something on the head of a stroke patient, for example, how much infarcted, so dead brain tissue, or how big a bleeding, a hemorrhage inside the brain. And they were using our software to do those measurements because, software, it's consistent. A doctor, sometimes in the morning he will do something, and in the afternoon it's going to be slightly different because a bit more tired. So for those research, consistency is also quite important. So that's how we started. There was a lot of interest from the pharmaceutical companies, and then later we thought, okay, let's bring this to the clinical workflow. Let's really help patients. And especially as a PhD candidate, usually you think, oh, I'm going to do this research, I'm going to go into a paper, put it in a drawer, and it's never actually going to help anyone.
Yeah.
So we are very proud that actually I'm still finishing it, right? But we finished our PhDs and we are bringing this to help the life of patients.
So your PhDs really have come to life through NICO.LAB.
Exactly.
Yeah.
So the papers that we wrote in the PhD became the product that we use today. Like really, so I have a paper about the cloud, a cloud architecture for high performance analysis of stroke patient data, and that's the same architecture that we use in our product, Stroke Viewer. So Mero has a paper about, she developed a new way of measuring how the vessels in the brain are behaving. Maybe I'm going to try to avoid being very medical here, because maybe the audience will have no clue what I'm talking about. It happened to me as well, right? I'm a computer scientist. So when I moved from Brazil to the hospital, 50% of the words they're talking, I just had no clue what they're talking about. So I'm going to try to keep it easy to understand. But anyway, so our CEO, she developed something like an algorithm to measure something specific in the brain. That based on that, you can basically determine if this patient will. It still makes sense to treat this patient, yes or no. And yeah, so her research is just it's part of our product as well. So yeah, that's basically bringing the whole PhD research to life. That's what we do, and we still do a lot of research actually here in the company. It's also a nice part of the work we do.
Yeah, no, awesome. So I think you're sort of living out most PhD candidates' dreams, right? At the moment, which is fantastic. But just on that, I noticed I just wanted to say, I noticed that you said that when you came from Brazil as a computer scientist into IMC, and you didn't know like 50% of the words because they're medical. Like you were just like, I've not been in this domain. I don't really know what I'm talking about as of yet. So how did you find that transition?
Yeah, so I mean, it's funny because I always thought, how hard can it be? It's just an image. So it's just bits. It's just grayscale values in a matrix. So it turns out it can be pretty hard. Let me tell you that. I think what it was great about the research we have done, it was a multidisciplinary team. So I was working. So I was the computer scientist, software engineer. There was also a radiologist in training working together with us. There is also like our CEO Meryl. She's a technical medicine, so she's in between. She understands a lot more about the medical space, but she also can code. So we had all these flavors of medical and technical, and we've been working together. So that helped a lot. So I learned a lot from those guys, and also you just learned a lot by just being exposed and talking with the doctors. So it was quite a smooth transition, right? So when I look back, I was like, oh my God, I know so much about stroke as a computer scientist. But it went gradually, so I don't really notice. Like for example, now when we hire a new engineer in the company as well, so we have as part of our onboarding process, they get a crash course on stroke because it's actually now back to my naive approach. There is quite a lot of biological processes and just the anatomy itself, like all that knowledge, you can take advantage of that to improve whatever method you are developing, in whatever image processing technique you're using. So it's important to be like in a multidisciplinary team working together.
Yeah, no, for sure. Okay, so just to give an idea of timelines, you were there. When did you join IMC?
Yes, 2013. And I think, maybe my memory completely tricks on me, but the famous Mr. Clink Trial started in 2012. This sounds, I think, something like that. I might be off by a few years. So
that was released in 2014, 2015, Mr. Clink?
Yes, exactly. Yeah. So basically, we've been working as part of the Mr. Clink research, right? So which was the first time that they proved that the mechanical removal of blood clots in the brain of stroke patients was an effective treatment. Before that, you would only use this clot dissolving agent. So I always, to explain to my fellow engineers, I always tell them, it's like, when you have your pipes on your sink obstructed, and then you try to put those acids to dissolve, and I don't know for you, but for me, that never works. And then you have to go with a wire and take it out. So so that's exactly what they did in a stroke. Maybe the doctors won't hear me saying that. It's gonna, it's a gross simplification, but yeah. So before the Mr. Clink trial, they were only using these acids to dissolve the clot obstructing an artery in your brain. Then after that, they showed that going with a wire, a catheter, and taking it out mechanically was very, very effective, like super effective. Like that, it's I mean, it changed the stroke care in the world, basically. Right? So and luckily we've been involved in that research as well. And
awesome. And that was pretty much that was like a change in the therapy and how you treat strokes. So
Yes.
it's almost like when it comes to diagnostics and the use of AI, it's a bit like a chicken and an egg. There's not really too much point if you put lots of investment, lots of R&D into diagnosing something using AI if you've got no therapeutic behind it.
Absolutely. Absolutely.
So
yeah. So
I guess you were involved with the egg, and now you're creating the chicken.
yeah. And both were in the making at the same time.
Yeah.
So yeah, no, this is a great point what you're saying. So it's also one of the interesting things of using AI in a stroke. So basically what we do, it's select the right patient for the right treatment. And AI plays a major role, not only in just, we are always limited by the performance. Well, again, I'm simplifying a little bit, but we use the humans as ground truth. So we always have to compare against the human. But what AI is really good, it can do analysis of the data much faster than a human can do, and the AI never gets tired, right?
Yeah.
So in an acute setting, there is a lot of value of applying AI. Because, for example, I see a lot of AI algorithms being used, for example, for delineating cancer tumors or things like that. But that's not so. It's not so urgent, right? So if you can just wait for a long time, the doctor can do that later on the week. There is no urgency. But in our case, there is a lot of urgency, and the AI plays just a major role in speeding up that process. Yeah. So we have the product live in several hospitals here in the Netherlands, and we already shown that it's quite a significant impact in terms of reducing the time to treat the patient. And in stroke care, time is very critical because the brain is just dying as the more you wait to remove that blood clot, for example. So you have to do it very fast.
What are the, I'm sure you've got them, the stats or that research has shown, sort of how many minutes if you save a certain amount of minutes, it saves a certain amount of months or years. So, do you have them to hand?
Yeah. So we know, for example, every 1 minute that you speed up the assessment of stroke patient, they gain, depends on the paper, right? But some say 27 days of healthy living, some say 22. But it's 22 days per minute. So every minute counts, right? I mean, we could Google and look it up, how many kilometers of synapses die per second. It's crazy. Also in terms of costs as well. So there's been a recent paper about the financial impact of stroke in US. And if I remember correctly, I think on average, every 1 minute translates to $1,000. So again, if you save 1 minute, if you speed up the assessment of stroke patient, the time to treatment in 1 minute, that will save the hospital or the healthcare system around $1,000. So it's quite a lot of substantial impact, right? Yeah.
And when you were, because this is emergency care, isn't it? It's time pressurized. Like you said, there's a difference if you go to diagnosing breast cancer or lung cancer or heart disease, for example. It's a little bit different because it's not time pressured. It is more acute. So I guess the workflow is different. The patient workflow is different, and diagnostic workflow is different. What challenges have you found in implementing that in a different setting for this time pressured?
A lot of challenges, man, because no, seriously, but that's the fun part of the work, right?
Yeah.
So to start with, those images are quite big. Like, so how does it work for us? The patient is brought to the hospital. Like, I have symptoms of stroke, call an ambulance. They brought me to the nearest hospital, right? The nearest one, because the fastest the better. Then they're going to scan my head with a CT scanner. That data, it's uploaded to Stroke Viewer, our product, on the cloud, and then we do the analysis. But we're talking about sometimes gigabytes of data, and we have to do everything, as I told you, every second counts. So one of our main bottlenecks is just the upload of the data. Like, takes sometimes 40 seconds. Here you're really fighting for every little second. Then once the data is uploaded, for example, in the case of the first scan, we analyze the entire head of the patient within like 30 seconds. Depends on how big the image is, and then the doctor gets a result. So to make sure that this whole system is super smooth and very effective, there is a lot going on behind the scenes. Also, another difficulties that we have is the fact that, if you go to Amazon or Google and you just want to, people always use this example, classify a picture of a cat or a dog, that you can pretty easily have the whole Amazon infrastructure managing that AI model for you, because it's very simple. You just have a small image that you send and you get the result, and everything it's done really nicely. You, as a company, don't have to worry so much about infrastructure. But our case is different. So the whole orchestration of the AI services is built by us because it's specific, right? So everything is complicated for us. So you're dealing with very big images, and it has to be done very, very fast at the speed of what you need. And also it has to be cost effective, because you could also make it very, very fast, but it would cost a lot of money. And we all know that healthcare is something expensive. So you also want to make sure that our product it's cost effective, so it can be used with biggest amount of patients in the world.
Yeah. And was there any decisions that you made early on that was to set up in that direction?
Yes. So right at the beginning when we started, we just decided we're going to do it cloud-based, and there were many reasons for that.
That would have been quite novel back then.
It was back then. To be very transparent with you, a lot of doctors said like, no way this is going to happen.
Yeah, 100%.
Yeah, they were just like, I'm not going to put my images, my patient data on a cloud somewhere. It has to be on premises. So they just think of, they want to have a box inside the hospital. Yeah, a box that they can kick when they are angry at it. So but we are also a small company, and we just thought it just makes way more sense to have it on the cloud. I mean, the guys, every time there is an update, we update our product every week. For a medical device company, that's quite impressive. People on other domains might think, that's not a big deal. But as a medical device, that's quite a big deal. There is a lot of regulation and tests and validations that we have to perform. So we do that every week. Also, that the fact that the data is on the cloud, it's pretty easy to share the data, like a peripheral hospital can share patient data in a secure, of course, in a very, very secure way with the comprehensive center. So that also, to give an idea, sometimes it would happen that you send a patient, the patient comes to a small hospital, they scan ahead, okay, this patient needs to be transferred to a big hospital to do this mechanical removal of the blood clot. But there was no way to share the data. So the patient had to be scanned again. And even if it's just 10 minutes or 20 minutes, as I mentioned before, it has quite a huge impact. So nowadays with our product, the doctors can even
my lights have gone off. It's been an interesting recording. Give me 1 second.
A lot of technical problems.
So we've had electricity go down on Renan's side, lights go off. Mobile data.
On your side, well, we will manage for sure. But I was just saying that when the fact that the images are on the cloud, the doctors don't need to scan again. So sometimes they can even start doing the planning of the procedure while the patient is in ambulance. So that saves a lot of time, because
I see. So you can put your software platform in the ambulance, so the diagnosis is done before they get to the hospital.
No. So so there are two steps, right? First,
Right.
the patient goes to the peripheral hospital, then they scan their head, and then they find out, okay, this guy can do the mechanical removal of the clot, but not everyone can do that. It's a pretty complicated procedure.
I see.
They have to transfer to this other hospital. While the patient is on transfer in an ambulance, the patients at the comprehensive hospital, because they already have the images on the cloud, they can already prepare everything. So by the time the
I
patient
see.
arrives, they don't need to scan then again. They just know what to do, so they just do it. So that saves a lot of time as well.
Oh, I see.
And
So
that,
because you're in the cloud, they can pass them through. If you're not in the cloud, then
I would have to physically, somehow find a way
take
to
it.
copy the data. Yeah, exactly. So it would be more time consuming. That was what they were using before here in the north of North Holland. They were using a system that gets the data and then pass it to a server somewhere and then push it to the on-premise services in the hospital. And that would take sometimes 40 minutes. And 40 minutes is just too much. We can't wait.
Yeah, no. And just want to delve into your role at Nikolab as CTO. Because there'll be people who are listening to this who are CTOs, who are CEOs, CSOs, who are in their PhD and looking to achieve that. So I guess it'd be good to know what your secrets to success is at the moment.
Oh wow, man! I think
have any?
that's a fun question. So, sometimes I tell like my first. I mean, I've been studying my whole life, right? You know, bachelor, master, PhD, and then my first job was CTO. So it's like but I've talked with a lot of other CTOs, you know, just to find out as well, just to learn from them. And most people say like, well, that's a job that you define basically your tasks, right? So here at Nikolab, I used to do a lot of technical stuff, coding. So the hemorrhage segmentation algorithm was first version was built by me. The architecture of the cloud was also defined during my PhD as well. But you know, the more that the company grows, I kind of get involved with everything here. I think if there is one I don't know secret to success is just like just be proactive. I just do whatever it takes, you know. So from managing the IT infrastructure to designing the first logo of the company to talking to the clients. I've been in many meetings with clients. You need to be able to adapt because you never know where there's going to be a gap in your team, and sometimes it comes to your lap and you just have to deal with it. Yeah. So that's also what we look for when we are hiring someone. We don't care very much about, you know, oh, I program in Java or I program in C++. You know, computer programming languages anyone can learn. That's not a problem. But if you're smart, if you're proactive, you know, if you see a problem, you go there and just try to fix it. That's I think that's an important attitude. And you're gonna make mistakes, man. We make mistakes, but you learn from it. And you and then you go ahead. So
definitely. You said you asked for advice from other CTOs and stuff. Is there anyone that's particularly helped you recently or in the past?
No. I mean, like everyone is just figuring things out, especially in this domain with AI. Things are changing so fast. You just have to trust your instincts as well. There is no. It would be if there was a nice recipe. It would be on a booth. You would sell.
Everyone would do it.
Everyone would move. No, you. I mean, everyone is in a different situation. Every company has particular things. What I mean, I'm a very science-driven guy. That has its pros and has its cons. So every time I'm trying to make a decision, I do a very quick Google Scholar research to see what is the state of the art in this domain here. What can we do? But sometimes you just have to, like for example, when we developed our clot localization algorithm. I was just talking with our CEOs, like, I'm sure we can do it. You know, it's going to take some time. It's going to take some effort, but we can do it. And we were the first company to do that, to have a AI model that not only detect a blood clot, but shows where it is. Because, you know, with AI, it's very easy for you to quickly build a prototype, you know, just train and you have something working. But you also need to make sure that it's useful. And the doctors, for example, just telling them, yeah, there is a blood clot in the CT scan, it's not so helpful, because they still have to go and look where it is, you know, just a simple classifier. So we had to find also where it is and show which image features the AI were using to come up with that decision. So I guess this combination of listening to your customers and trying to build something useful and using the technology just as a tool, right, to achieve that goal. I'm really let's say lucky to have, you know, this interdisciplinary team here that we have a lot of interesting discussions and sessions on a weekly basis, and yeah, that definitely helps.
Curious environments is what I always say. You can, if you can foster and create a curious environment, it leads to success. You know, you don't want 40 of the same people programming the same thing, the same background from the same university. You know,
no, it's
you need
it's funny. It's funny that you mentioned
combination
that.
of ideas, right?
Yeah. At some point in time, I think we had 2 people from the Netherlands, but apart from that, everyone else in the company was from a different country, different background.
Wow.
Yeah, so it's very, very international.
It's so cool. What's your biggest success?
Well, I am really proud of being, you know, this company that just pushed for the cloud architecture. I'm also really proud of being the first one to have the cloud localization available. And well, I mean, we have a lot more interesting stuff that you're gonna see on our LinkedIn page in the future that I'm also really confident about. But yeah, I think. And there was one particular moment that for me was really, really special, was when we were making sure that our first clients would use Stroke Viewer, right? We installed everything, and I think during a Friday, I mean, I worked a little bit on the weekend as well. And then it was gonna be live Monday, 9 a.m. And then Monday, 9 a.m., there was the first patient going through the platform. So that's something that I'm really proud, you know.
Well,
we know
straight away. It was
straight away, like
wow.
like almost like was like, is this right, you know? But straight away, and it was so exciting to see all the work you've been putting into this for years finally coming and helping someone. And that was that for me was just okay, you know. That's it. I don't need more. But yeah, so that was I think the biggest highlight so far. Because, you know, after the first one, then you get 100, 200, 1,000 patients. Then I mean, it's super special. But the first one, that moment, it's very special to me.
Yeah, no, I can. Yeah, it would. I don't know what it would be like. I don't know. Imagine like it's like your baby going out and proving what it is, right? I can't even really imagine what that must have felt like, but it must have been an amazing experience for all of you, but just mainly yourself, because you have effectively built most of it, and the AI behind it.
The whole team. We were, it was indeed it was a really special time, and yeah, you know, it's there was still, I mean, there is always a space for improvement. Like, there's also one of the challenges as being a science-oriented guy like I am. You always sometimes, but we still can do this better. We can do this better and this and this. But sometimes you have to, you know, put the baby out there.
Yeah. Let it try and ride the bike with the stabilizers
exactly.
off.
Take away the supporting wheels and see how it goes. You also learn a lot by doing that as well. That's important.
Yeah. Like, sure. And one thing I'm really keen to help you to stress to people listening, we've spoken a lot about the product stroke viewer that you guys have, and the fact that it utilizes AI to diagnose strokes, but it really is this cloud architecture that you have implemented. It was very novel with a lot of pushback early on from radiologists, but that sets you aside from other products.
We've seen now that there is a lot of people moving in and you know, just trying to do the same. I mean, I would say that the combination is the great part, right? Because not only what we are also really proud is that the architecture that we are building here, it's something that can also in the future enable us to bring the more let's say unique types of AI algorithms, deploy them again in the emergent setting in a fast, reliable, and cost-effective way. So there's also something that I'm really proud of the work we've been doing. Of course, the AI as well. It's very challenging to develop, and that's also important to. I mean, that's actually one of the most important things, right? But this combination, right, and the combination, the two things working smooth together, I think that makes us quite unique from the engineering perspective. Like, so if you have engineers listening to us and looking for an interesting challenge, just drop us a message.
100%. So you've set your cloud architecture up in a way that will enable you to branch out into other areas of emergency care, or to keep adapting your current one for stroke. How have you set it out for long-term scalability, let's say?
I mean, a stroke, 1 in every 6 people will have a stroke, right? And and also because of people live longer and poor diet choices and things like that, the number of stroke patients is only increasing in the developed countries. So it's the second leading cause of death in the world. So sometimes I also make the joke, like, Elon Musk is with the self-driving car is trying to solve cause of death number 10, and Bill Gates with he has something with toilets in Africa. Diarrhea disease is like reason of death number 8, and here at Nikolab we are solving number 2.
Number 2.
So it's really high in the hierarchy of impact. So we want to do stroke well, and that's the main focus, right? But we do see opportunities to apply the same approach in other emergency areas in the future. Absolutely, yes. So that's also something that we will do in the future. Also because right now we also depend on the types of treatment that are available for a stroke. What we do is we select people for a stroke treatment, and maybe in the future, if there are more unique, different ways of treating stroke treatments, we're going to have to build more AI algorithms to select for those specific type of treatments. As well. So that is always, we continue in stroke, and then we want to solve stroke the best we can. But I mean, all the knowledge that we built and the architecture we built can also definitely help people in other acute or emergency areas, of course. And we are in the business of helping people, so why not, right?
No, absolutely. So staying within emergency care is going to be your primacy, but it's also driven slightly by the advancing in how you treat a stroke as well. If there are more nuanced areas, effectively, like if there's going to be a Mr. Clean 2.0 or something like that, that will help you drive into another area.
Exactly.
But could you use your cloud architecture for places that haven't got the infrastructure, that haven't got the hardware, to help those areas as well?
Yes, I mean, if there is an internet connection, we can help. That's the bare minimum infrastructure that we need. So it's as simple as that. So the hospitals don't need much. They have a cable with internet where they can push the data to us. We do the rest, and they see everything. They see everything on their browser. So even the rendering of the images are done on the server side and is streamed to them. And the way we do that is, again, to avoid pushing data, is to make it very, very very effective. Like we don't want to push data to the browser that takes time to load images. We want everything to be as smooth as possible. So the bare minimum we need is an internet connection. Yeah, and if you have that,
So have you looked into helping? I'm thinking of areas of the world where they haven't got massive healthcare systems.
Yes.
That haven't
I mean,
got
I'm from
widely
Brazil,
available.
Right?
So,
yeah. So no, we do have. We have done some. I think it's still ongoing. I have to look it up.
Yeah.
We have some pilots going on in Latin America. So in a country like the Netherlands, all hospitals have CT scanners. They can do more advanced type of imaging. In other areas in the world, they cannot. But actually, I think those areas are the ones that benefit the most from AI, because we can, use the machine intelligence to use that, let's see, not so, yeah. Ooh, are you still there? There was a lot of flipping.
No, what I was going to say, there's a bigger gap for you to close. If you know, so there's a skills gap, there's an infrastructure gap, there's a hardware, there's a bigger gap for you to close in Brazil than there is in the Netherlands. So almost the impact is bigger.
Absolutely, you said it perfectly. So no, seriously, in countries like Brazil, for example, the distances to move patients are much bigger, right? So that help. So that means that making the decisions right at the beginning have a way bigger impact. They don't have all the type of imaging as well. So we are also developing biomarkers here that can do the same advanced processes that we have in more advanced imaging and more advanced CT scanners, but to the more simple ones as well. Sometimes they don't even have the ability to see the entire head of the patient. They just scan like a small slice here. So they definitely can benefit a lot more. And we are doing some pilots, and as I said, in Latin America, because well, I mean, I'm from there, so it would be nice to help people there as well.
Yeah, that's awesome. Because I noticed that there are some other people in the space who utilize cloud and have done for a little while now, who are seeing that as an area of I don't know, social responsibility to help that area as well, off the back of the funding and the revenue that you'll get in both Europe and America, to help those areas as well, because it isn't a massive it's like an extension rather than a new thing that you'd be doing for it. So I wondered though, because we had an episode with Blackford analysis.
I didn't hear that. An episode with
we had an episode with Blackford analysis, and I asked their CEO Ben Panther the same question, because they're like a cloud software platform where third-party imaging companies can go on and utilize their implementation for hospitals. So just because I know implementing it is quite challenging sometimes. But I asked him how COVID has affected the uptake in cloud for hospitals. I don't know if you guys have seen a more positive approach to using cloud in the past year and a half from hospitals. Or
that was a great. So because we have this cloud-based viewer. That is during the COVID, some doctors, some radiologists approached us to use actually Stroke Viewer for remote viewing of lung CT scans, because they could work remotely, and they were so happy with the work we've been doing. So that's something that we did as well. We did join a consortium to try to use AI to help COVID patients. But one of the side effects of COVID, I don't know if you heard, is that sometimes it leads to more blood clots, and blood clots is what causes stroke. So for us, the work actually didn't decrease. Actually, it became even more relevant to use Stroke Viewer.
Yeah, exactly. Yeah, and I think that's been the impact of COVID, it's accelerated the work of people like yourself, and have really highlighted the need for these software platforms, for these tools to both democratize medicine further, but also to harness remote diagnostics if possible. And you know, we're getting to a world, we've realized now that we don't all need to be in the same room to do something. You know, I can be in London.
So yeah, exactly. So the fact that they could, you know, see the patient, I mean, let me emphasize here one more time that, you know, it's everything safe, no data is transferred for local devices. I said just streamed, because, you know, also people have a little bit sometimes a bad perception of the cloud. They think it's not safe, but actually if it's done right, it can be actually more safe than, because you have experts taking care of your data instead of, you know, your local machines there inside the hospital. So because I mean,
someone could just break in and take the machine. Like, someone can hack the machine. It's almost like I have an airplane analogy, because some people think, and even myself to be fair, that the airplanes are not the best environment for a human being to be in, because they can go wrong. And if it does go wrong, it is a big problem. But they are so much safer than driving a car, because they're almost over safe to make sure that they're okay. So I reckon the cloud's gone in the same direction, that it's like it's over safe, it's so secure to alleviate those concerns.
It's a great analogy. That's exactly the situation. It's about the perception, right? The perception is different, but it's definitely way safer. So yeah, we are also very proud that, you know, we yearly we hire some, you know, hackers to try to hack us and find vulnerabilities on our system, and we always get really good grade on that. So it's cloud is safe and is here to help, right? I mean,
definitely. Well, I've had an absolute pleasure speaking to you. There's been a couple of challenges with lights and internet connections and construction works. So,
a lot of things going on today indeed, but well, now it's quiet for 5 minutes.
I hope everyone listening and watching managed to take from it what I have, which has been fantastic and fascinating conversation. So thank you very much for your time, and I guess it's a big year for you guys at Nikolab, and I guess everyone is going to be watching with bated breath how you go to the next level. And if there's anyone wanting to join, if there's anyone wanting to ask more questions, I imagine just reach out to you on LinkedIn, or
you can reach out to me on LinkedIn. You can just go to NICO.LAB.com and drop us a message in the contact page. Yes, we are. I mean, we are really expanding the team, and you need help everywhere. So, and as I said, you know, we value smart and proactive, dedicated people. So just contact us, and we continue the conversation there.
Yeah, awesome. Thank you very much, man. Really appreciate it.
Thanks, Nick. Bye bye.